Our sun. It's a constant presence in our lives, a source of warmth, light, and life itself. But the sun is much more than just a bright light in the sky. This celestial giant is a churning ball of plasma, a colossal nuclear reactor that holds our solar system together. Every day, the sun bathes us in energy. It drives our weather. It sustains life on Earth. But the sun also possesses a hidden power, a potential for explosive events that can reach far beyond its fiery surface. To understand solar storms, we must first understand the sun itself. Deep within its core, a nuclear furnace rages. Hydrogen atoms fuse, releasing tremendous energy. This energy travels through the sun's layers. The convective zone carries it further. Finally, the photosphere, the sun's visible surface. The sun's energy isn't always calm. The sun is dynamic and ever-changing. Its surface writhes and churns. Giant plasma loops twist above the photosphere. Magnetic fields drive the sun's explosive nature. They store energy and unleash solar storms. The sun's magnetic fields are like invisible threads, woven through its fiery atmosphere. These fields are generated deep within the sun's convective zone, where churning plasma creates electric currents that, in turn, produce magnetic fields. These fields are not static. They constantly twist, turn, and interact with each other. Imagine a colossal game of cosmic twister played out on the sun's surface. As these magnetic fields move and interact, they can become tangled and stressed. Like a rubber band stretched to its limit, these fields store tremendous amounts of energy. Sometimes, these tangled magnetic fields realign themselves, snapping back into a lower energy configuration. This sudden release of energy triggers a solar storm, a dramatic outburst that can send waves of charged particles and radiation hurtling through space. One of the most common types of solar storms is the solar flare. These are sudden, intense bursts of radiation that originate from the release of magnetic energy near sunspots, which are cooler, darker areas on the sun's surface. Imagine a colossal flashbulb going off, releasing a blinding burst of light and energy. That's a solar flare. Solar flares can have a significant impact on Earth, particularly on our technology. The radiation from these flares can interfere with radio communications, disrupting GPS signals and even causing blackouts. In our increasingly interconnected world, where communication and navigation systems are essential, solar flares pose a real and present challenge. Section 3. Coronal mass ejections, eruptions of epic proportions. While solar flares are like warning shots, coronal mass ejections, or CMEs, are the sun's heavy artillery. These are colossal eruptions of plasma and magnetic field from the sun's corona, the outermost layer of its atmosphere. Imagine billions of tons of superheated gas, threaded with magnetic fields, being blasted into space at speeds of millions of miles per hour. That's the awe-inspiring power of a CME. When a CME is directed towards Earth, it can trigger a geomagnetic storm. As the CME's magnetic field interacts with Earth's magnetic field, it can compress and distort our planet's protective shield. This can lead to a cascade of effects, from spectacular auroral displays to potentially disruptive currents in power grids and satellites. Section 1. Solar winds. A constant cosmic breeze. Beyond the dramatic explosions of flares and CMEs, the sun is constantly releasing a stream of charged particles known as the solar wind. This constant outflow of plasma carries with it the sun's magnetic field, creating a vast magnetic bubble around the solar system called the heliosphere. Think of it as a never-ending cosmic breeze, gently pushing against everything in its path. While the solar wind is much less dense than the material ejected in a CME, it's always present, constantly shaping the environment around our planet and beyond. The solar wind's influence extends far beyond Earth. reaching the furthest planets and even interacting with the interstellar medium, the diffuse material that exists between star systems. Section 2. Earth's magnetic shield. A guardian against the storm. Fortunately for us, Earth is not defenseless against the onslaught of solar storms. Our planet possesses a powerful magnetic field, generated by the churning molten iron in its core. This magnetic field acts as a shield, deflecting most of the charged particles and radiation from the Sun. Picture a giant invisible bubble surrounding our planet, protecting us from the harshest elements of space weather. However, this shield isn't impenetrable. During intense solar storms, some of the Sun's energy can penetrate Earth's magnetic defenses. This can have a range of effects, from disrupting radio communications to inducing electric currents in power grids and pipelines. Understanding and predicting these space weather events is crucial for protecting our technological infrastructure and ensuring the safety of astronauts in space. Section 3. Auroras. Dancing lights of the polar skies. Solar storms create breathtaking auroras. Charged particles from the Sun collide with Earth's atmosphere, causing vibrant colors of green, red, blue, and purple. The northern lights, or aurora borealis, and the southern lights, or aurora australis, are visible near Earth's magnetic poles. These celestial ballets of light connect us to the Sun's power and space events millions of miles away. Section 1. When solar storms reach Earth. While the Sun might seem unimaginably distant, a colossal 93 million miles away, the effects of its storms can be felt right here on Earth. When a coronal mass ejection, or CME, erupts from the Sun and hurtles towards our planet, it carries with it a piece of the Sun's magnetic field. This magnetic field can interact with Earth's own magnetic field, like two invisible forces clashing in a cosmic ballet. The impact of a CME can compress Earth's magnetic field, creating a geomagnetic storm. This disturbance can have a ripple effect on our planet's technological systems. Imagine a pebble dropped into a still pond, sending out ripples that disturb the tranquility of the water. Similarly, a geomagnetic storm can disrupt the delicate balance of our planet's electromagnetic environment. Section 2. The technological tightrope. In today's technology-dependent world, we walk a tightrope above the potential disruptions of space weather. Satellites orbiting high above Earth are particularly vulnerable to the onslaught of charged particles unleashed by solar storms. These particles can interfere with satellite electronics, disrupting communication networks, GPS navigation, and even television broadcasts. On the ground, power grids, the lifelines of our modern world, face their own set of challenges. Geomagnetic storms can induce powerful currents in long conductors, such as power lines, leading to voltage fluctuations and even widespread blackouts. The delicate balance of our interconnected world can be thrown into disarray by the invisible forces unleashed by our Sun. The year was 1859. The world was a far different place, on the cusp of the telecommunications revolution. Then, in early September, the Sun unleashed a solar storm of unprecedented magnitude, now known as the Carrington event. This event serves as a stark reminder of the immense power of our Sun and the potential consequences of its most intense outbursts. Auroras, typically confined to high latitudes, lit up the skies as far south as the Caribbean. Telegraph systems, the cutting-edge technology of the time, went haywire, with operators reporting sparks flying from their equipment. The Carrington event, though occurring in a less technologically reliant era, provides a glimpse into the potential disruptions that a similar storm could cause in our modern world. While Earth feels the impact of solar storms, our planet's magnetic field acts as a protective shield, deflecting the brunt of the Sun's energetic onslaught. But what about other planets in our solar system? Let's journey to Mars, our rusty red neighbor, to witness the stark consequences of a world without a strong global magnetic field. Billions of years ago, Mars may have been a very different place, with a thicker atmosphere and perhaps even oceans of liquid water. However, over eons, the relentless bombardment of solar wind stripped away much of Mars's atmosphere, leaving behind the thin, arid environment we see today. Without a strong magnetic field to deflect the solar wind's onslaught, Mars stands exposed, a stark reminder of the power of our Sun. Venturing further into the outer solar system, we encounter the gas giants, Jupiter, Saturn, Uranus, and Neptune. These behemoths, composed mostly of hydrogen and helium, possess magnetic fields that dwarf Earth's in both size and intensity. Jupiter, the largest planet in our solar system, boasts a magnetic field so powerful that it creates a magnetosphere that extends millions of miles into space, forming a vast, invisible bubble around the planet. When solar storms reach these magnetic behemoths, they trigger auroral displays that are nothing short of spectacular. Jupiter's auroras, for instance, are thousands of times more energetic than those on Earth, painting its polar regions with swirling curtains of light. These auroras serve as dazzling reminders of the invisible forces at play in our solar system. The journey through our solar system reveals a profound truth. The Sun is not merely a source of light and warmth, but a dynamic force that shapes the very fabric of its surroundings. Solar storms, those explosive outbursts of energy, leave their mark on every planet, moon, and asteroid within the Sun's domain. From the atmospheric stripping of Mars to the dazzling auroras of the gas giants, solar storms remind us that we are inextricably linked to the activity of our star. Understanding these cosmic events, their causes, and their effects, is not merely an academic pursuit, but a crucial step in comprehending the delicate balance of our solar system and the forces that have shaped our planetary neighborhood. The annals of history hold echoes of solar storms past, events that etched their presence in the scientific record and human memory. The Carrington event of 1859, witnessed by Richard Carrington, reminds us of the Sun's immense power and potential disruption. Telegraph systems went haywire, with operators reporting electric shocks, sparks, and fires. Auroras painted the skies as far south as Cuba and Hawaii. The Carrington event is a reminder of the potential consequences of a similar storm today. Imagine widespread blackouts, disrupted communication networks, and crippled GPS systems. The Carrington event serves as a potent reminder of our planet's vulnerability to the Sun's capricious nature. Today, we are not caught off guard by the Sun's fiery outbursts. A fleet of spacecraft acts as our sentinels, keeping a watchful eye on our star's every move. These observatories provide an unprecedented view of the Sun's activity, allowing early warnings of potential impacts on Earth. NASA's Solar Dynamics Observatory, launched in 2010, captures high-resolution images of the Sun. SDO's observations have revolutionized our understanding of the Sun's magnetic field. Imagine witnessing the birth and evolution of solar flares and coronal mass ejections in real time. NASA's Parker Solar Probe, launched in 2018, dives through the Sun's corona. This mission endures extreme temperatures to gather data on the solar wind. The Parker Solar Probe unlocks the secrets of the Sun's atmosphere. These sentinels provide data to help us understand and predict the Sun's behavior. As we venture further into space, our reliance on these technologies will grow, making it crucial to heed the warnings of our solar sentinels. As we gaze up at the night sky, awash in the soft glow of starlight, it's easy to feel a sense of awe and wonder at the vastness of the cosmos. Yet, amidst this celestial tapestry, it's our own star, the Sun, that holds the key to our existence and our future. The Sun's fiery outbursts can disrupt our technological civilization. Solar storms remind us of our connection to the celestial dance. They highlight the balance between our reliance on technology and the Sun's unpredictable nature. Understanding and predicting these cosmic events is crucial for safeguarding our infrastructure. As we venture further into space, awareness of space weather becomes critical. Just as we check the weather forecast, we must heed space weather warnings. The Sun, our constant companion, holds the key to unlocking the mysteries of our solar system. By studying its outbursts, we understand the processes that govern stars and planetary systems. Our journey of discovery is intertwined with the sun's energy and influence on our world and future.